Hi guys, welcome back. In this tutorial we are going to implement basic connectivity between two PCs in Packet Tracer. We are going to do that by first performing a basic configuration on switch 1 and switch 2. We're going to then configure the PCs, and we're also going to configure the switch management interface. At this point at the beginning, our PCs are unable to communicate with each other. If I were to access the command line, which I've done previously, I still have my command in there. If I were to ping my PC number 2, which has an IP address of 192.168.1.2, you can see that this PC is unable to communicate with PC number 2. That's because these basic configurations have not been put in place, and the ping command is a very useful command that you can use throughout your CCNA career to help you with verifying connectivity between any devices. We're also going to use some show commands to verify configurations on our Cisco network devices as well. So to begin, first we're going to perform those basic configurations on switch 1 and switch 2. We'll begin by configuring a host name on switch 1. I'm going to go ahead and open up switch 1, and back at the beginning here I am in privilege mode. I'm going to type enable to access privilege exec mode. From privilege exec mode I am going to access config T. I'm going to access global configuration mode. I'm going to configure hostname S1. So hostname S1, enter. Now I'm going to configure the console and privilege exec mode passwords, and we're going to do that by using Cisco for the console password, and we're going to use class for the privilege exec mode password. So I'm going to go to line configuration mode, line con 0, configure my console password. I'm going to type in password, and I'm going to type in Cisco to configure that password. What's that magic command that we must type in order to activate that password? Login. Enter. Now I'm going to exit back to global configuration, and I'm going to specify that I want a password here, and I want that password name to be class. Excuse me, enable password class. Step 3. Verify the password configurations for S1. We can do that by doing show run. And here I can see my enable password is set to class. I have my hostname 1. I have my console password, which is Cisco. Next, we're going to configure a message of the day banner. We're going to go to banner, type in banner, MOTD, quotation mark, and that banner name should read authorized access only. Violators will be prosecuted to the full extent of the law. Done. Next, we're going to save the configuration file to NVRAM. What command are we going to use to do that? We're going to do copy, run, start. We'll save it to the NVRAM, which is non-volatile RAM, which allows us to retain our settings in the event that we lose power or reload the switch. These are the configurations that will be present upon startup. We're going to repeat these same steps 1 to 5 for S2. So we'll go ahead and close that. We'll go to S2. I'm going to access the command line. I'm going to type enable to get to privilege exec mode. From privilege exec, conf T for global configuration mode. Now that I'm in global configuration mode, I'm going to give this a host name of S2 because it's switch number 2. We're going to use passwords here, Cisco and class for the console and privilege exec mode passwords respectively. So accessing the console, line configuration, line con 0, and we want that password to be Cisco. Magic command here, login. I'm going to exit out, and I'm going to set an enable password of class. How can I verify that both passwords were configured correctly? Well, we can go to do show run to show the running configuration. Here I can see that my enable password has been set as class, and I can see that my console password has been set to Cisco. All clear. Configure a message of the day banner. We're going to do the same as we did previously with switch 1. And that banner, command is banner, MOTD, quotation marks, authorize, access only, violators will be prosecuted to the full extent of the law. Enter. Banner done. We need to save the configurations to NVRAM, and how do we do that? Do copy, run, start. Enter. Next, we're going to configure the PCs. We're going to configure PC1 and PC2 with IP addresses. We're going to go to PC1 first. We're going to access the IP configuration. We're not going to use DHCP, Dynamic Host Configuration Protocol. That one uses a server to automatically receive IP addressing information. We're going to do a static configuration here. And on the IP addressing table here, we see that PC IP address for PC1 is 192.168.1.1. See if I can bring up this table for you all. So my PC1 has an IP address of 192.168.1.1. Here's my subnet mask, and PC2 is 192.168.1.2. So continuing on with PC1, 192.168.1.1. Subnet mask 255.255.255.0. We can go ahead and close that. Next, we're going to repeat the same steps for PC2. So PC2, IP configuration, 192.168.1.2, 255.255.255.0. We can go ahead and close that. Now we're going to test connectivity to the switches on PC1. We're going to try and ping the switch. Now our switch 1 has an IP address of 192.168.1.253. That information was also listed for us here, so I'll stop flipping the screen. But back at PC1, I am going to get to the command line, command prompt, and I am going to ping 192.168.1.253. And as you can see, we're not going anywhere. We are unable to ping S1. Why weren't we successful? Our PC does not know how to reach switch 1. Switch 1 does not have an IP address currently configured, so it does not have a means of communicating with other devices via IP addressing. So from our switch, we're going to configure switch 1 with an IP address. We're going to get back to the command line. Get this on top. Press enter. Alright, so switches can be used as plug-and-play devices, meaning they do not need to be configured for them to work. Switches forward information from one port to another based on media access control addresses. Those are MAC addresses. If this is the case, why would we configure it with an IP address? Well, if it needs to communicate from one device that's connected to one switch to another device connected on another switch, we will need to have IP addressing in place so that way the devices will know how to reach each other. What about when you're trying to drive to someone's home for the first time? You're going to visit a friend from work and you have never been to their home before. You need an address to know how to locate them. Same situation. So we are going to use the following commands to configure S1 with an IP address. So from my privilege exec mode, I am going to conf T to go to global configuration mode. We have interface VLAN 1, which is our default VLAN. We're going to add IP address 192.168.1.253. Oops. Subnet 255.255.255.0. No shut. I get the prompt here that VLAN 1 changed state to up. Line protocol and interface VLAN changed to state to up. So why do we need the no shut command? Because without the no shut command, it's shut down, and we are unable to communicate if our VLANs and ports are in a shutdown state. We are now going to configure S2 with IP addresses. So I'm going to close this window and I'm going to open S2. I'll get to the command prompt, command line. So we're going to use the information in the table to configure S2 with an IP address. Back at the addressing table, I see that S2 has a VLAN IP address of 192.168.1.254. And please take note that we are placing these IP addresses on the interfaces of the different VLANs on this switch. When it comes to routing, routers have IP addressing on a per port basis. However, with switches, you would configure these IP addresses on a per VLAN basis or for the entire switch itself, like through a switch virtual interface. So from my privilege exec mode, I'm going to conf T to get to global configuration mode, and I am going to set interface VLAN 1, enter, and I'm going to type in IP address 192.168.1.254, subnet mask 255.255.255.0, enter. I'm going to no shut it, and then I'm going to exit. We're going to verify the address configuration on switch 1 and switch 2. So we're going to type in show run to verify that information. Here I have interface VLAN 1. My IP address is here. Let's check the same on S1. On S1, show run. Here's my interface VLAN 1 and my IP addressing for VLAN 1. Next, we are going to verify the IP address configurations on S1 and S2 on using our interface brief command. So we're going to go back in on S1 and we're going to type show IP interface brief, which will allow me to see interfaces and IP address configuration information. So here I can see that I have 2 ports that are up. Here I can see I have 2 ports that are up on switch 1, of course, because one is connected to the PC and one is connected to the neighboring switch. I can also see that I have an interface for VLAN 1 that is configured, and it's in an up state with an IP address of 192.168.1.253. We will do the same on switch 2. And we'll go show IP interface brief. And here I have the same. I have a listing of all of my interfaces as well as their status. Notice that I have up and up, yes and up, for interface 1 and 2 for the PC and the switch that are connected to these ports. I also have a VLAN 1 interface that is currently up, and IP addressing on that is 192.168.1.254. So we need to we've done both the IP interface brief command to verify, and we've also used show run to verify that configuration as well. What command are we going to use to save the configuration file in RAM to NVRAM? We're going to do copy run start. That's to copy the running configuration to the startup configuration. So we're going to go copy run. Let me get back in config. copy, run, start. I was already in the correct mode, so I had to put do in front of my copy, run, start command. So from here, copy, run, start from privilege exec mode. If you're in global configuration mode, you'll have to place do in front of that command. And our configurations were saved. And then finally, we are going to verify network connectivity. We're going to do that by using the ping command, which is a very important command. And it's important that connectivity exists throughout the network. And typically when you're working on a large project, you want to test connectivity before you start building out. Make sure your basic infrastructure is in place correctly and that you're able to ping around to ensure that connectivity is in fact in place. We're going to ping S1 and S2's IP address from PC1 and PC2. So from PC1, I'll get back to my command prompt, and we want to ping S1 and S2's IP address. So S1's IP address is 192.168.1.253. That was my previous command, so I'm just going to hit the up arrow, and now I'm going to ping. We lost the first packet, which is okay. Sometimes that happens due to the ARP process that takes place where a device is trying to resolve an IP address with its associated MAC address. So it's trying to find who that IP address belongs to on the network, and that's perfectly fine. So we only lost 25% of our packets, 1 out of 4. Now we will do the same for PC2. We are going to, for PC1, we're going to ping switch 2. So we're going to ping 192.168.1.254. We lost our first packet again, but that's okay. We were able to get 75% success. If we were to do it again, it should be just fine. It's just that the first time, most of the time you will lose the first one, sometimes 2 packets. Alright, so PC1 is able to communicate with S1 and S2. Next, we want to ping the IP address for PC2. So let's go back in there. I closed it too soon. And we want to ping the IP address for S2. That IP address is 192.168.1.2. We can see that we were able to ping successfully with 0% loss. And finally, we want to ping the IP address for S1, S2, and for PC2. And we have already done those. Let's go to PC2 now. And let's make sure that we can ping everybody. So from PC2, we're going to ping S1. We'll begin there, 192.168.1.253. Lost our first packet, and that's okay. Now we're going to ping S1, which is 192. Sorry, that was S1 with the .253. We're going to ping S2, which is .254. Let's change that to 254. Next, we'll ping PC1, 192.168.1.1. And we were successful with all of our ping tests, and we have completed all the tasks at hand. We can also use the same ping command on the CLI on PC2. All pings should be successful. If your first ping result is 80%, retry. It should now be 100%. You will learn why a ping may fail the first time later in your studies. If you're unable to ping any of the devices, make sure you recheck all of your configurations for errors. And that concludes our tutorial for this session on implementing basic connectivity. I hope that this has been helpful for you, and we will see you next time.